Hi guys, happy Friday. We made it. Just a few more days of me teaching you this way, and I'll be back next week. We're just going to pick up right where we left off yesterday because I did hear that at least one class didn't get through the whole video, and a little bit of review isn't going to hurt anybody anyway. So yesterday we watched those videos, or that video that showed the different types of landscape regions that are created by glaciers, or actually I should say landscape features that are created by glaciers. They did describe how some of them were formed. I will tell you, the good news is that video had way more details than you'll need. Basically, what you need to know about all those different landscape features is that they're created by glaciers. So when you hear the words that they were using, like erratic or striations or U-shaped valleys, you should be having bells and whistles going off in your head saying, ooh, 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 those are created by glaciers. So you do need to be familiar with the things that glaciers create. What I need from you is to, in our notes, we need to make sure you have these 5 bullets about glaciers. I'm not sure if these printed up for you on page 8 or page 9. It sounds like we have 2 different variations of the packet, and we're going to fix that actually after we get these notes in our packet. I'm just going to make sure everybody knows what I'm talking about. Again, just give me a minute. So on either page 8 or page 9, wherever the box for glaciers is, we need to put these big ideas for glaciers. So these 5 bullets are going to go in the first box for glaciers. And you do need to understand that glaciers move by the force of gravity. So gravity pulling down on the glaciers is going to cause the glaciers to move. Glaciers move anything that's in their way. They pick up any size rocks. They can be rocks as small as a grain of sand or as big as a house. It doesn't matter how big the sediment is, glaciers will move it. On that same note, glaciers drop off unsorted sediments as they melt. Meaning, again, size of a car, size of a grain of sand, it doesn't matter. As they melt, glaciers drop off whatever it was they were carrying. Again, with those different landscape features, you do need to know, again, you don't need to know the details of how they formed, but you do need to know that glaciers create things like U-shaped valleys, striations, those were the scratches made from the glaciers on the rock underneath them. Grooves, those are basically really big scratches created by glaciers. Moraines, kettle lakes, drumlins, and outwash plains. Anytime you hear any of those words, again, I want you thinking, ooh, glaciers made those. So you need to know that those were made by glaciers. And then finally, you do need to realize that our whole local landscape was basically created by glaciers. You can see drumlins and U-shaped valleys, the Great Lakes, the Finger Lakes, those are all created by glaciers. So around here in the Northeast, almost everything was created by glaciers. So I'll give you like another minute to make sure this whole page is copied into your notes. And then what I just need to do is, oh, never mind, I'll just tell you when we get there. So I'll give you another minute. Okay, if you don't have that copied, go ahead and ask the teacher to pause it for you, or you can go back on your own time and get this back into your notes. But what we need to do right now is I need to make sure everybody's packets are the same. I know the ones I printed up early before break, I screwed that up somehow. I must have hit enter somewhere, and this pages 8 and 9 got messed up, and that was the cause of the problem. So I just want to make sure we're going to have to adjust the numbering. So here's what we're going to do. I am going to ask everybody to look at their page 8 right now. And if your page 8 looks like my page 8, so see how page 8, there's this big empty space underneath wind. If you have that, then this next minute or so is going to be aimed at you. So again, if you have glaciers on the top page over here like this, like mine, you're the one who I'm talking to right now. So everybody check their pages 8 and 9. If it looks like mine with glaciers at the top of page 9, we need to do some adjusting. So right now, if everybody who's got their packet that looks like mine, so page 9 has this big empty space, here's what I need you to do. So this page that was page 10, we need to cross it off and make it a page 9. This is only for the people who had the messed up packet like me. All right, then, and this can go for everybody. Everybody turn to this page that's got this picture of a glacier at the top and these rock layers at the bottom. So for the messed up packets like mine, this would have been page 11. I want you to cross it off and make that a page 10. Everybody else, this should already be your page 10. Double check that. All right, and then from then on, I just need you to flip through the packet, changing the numbers. So this page with this New York, Connecticut map at the top, change that to 11. Just keep turning the page then. So now we've got 12. I think you're going to get the point now. 13. 13's on this page. 14's got the sorting of sediments. 15 is this region's questions 1 through 6. 16 says save Buffalo's waterfront. That's page 16. 17 has these boxes at the top. 18's got this weird map at the top. So that's page 18. 19. 20 starts streams. 21, we've got the life cycle of a stream, old age, mature, and youth, or I guess I should have said youth, mature, old age. 22 is this one with this windy river. That's page 22. 23 says the formation of deltas. 24 has the map of the United States on it. 25 says I stream, you stream. I hope I'm back for this one. 26, drawing cross sections. 27, drainage patterns. 28, some regents questions. Whoops, where'd that go? 29, 2 empty boxes here. 30 should have these 3 empty boxes, hopefully. And that should be it. So the packet really should have ended. And this is for everybody. The packet should end, while I'm struggling, on page 30 here, where it says glaciers, running water, and waves. So hopefully that makes everybody now have the same page numbers, except for the only weird thing is those of you with a messed up packet, you have a 2-page 9s. That's the only weird thing. And in fact, that's where we're going to go right now, is wherever you have these boxes. I think this is on page 9 for everybody. So whether it's the first page 9 for the messed up packets, or I think the rest of you have them on this page. But anyway, we're going right here, Finger Lakes and Great Lakes. Sorry about that. Okay, so like I said, we are on I believe it's page 9 for everybody, and it says Great Lakes or Finger Lakes and then Great Lakes. And that's what we're going to make sure you understand. Oh, actually, we skipped sketching. Shoot. So before we go to Finger Lakes and Great Lakes, back to where we were writing a minute ago for glaciers. What I really wanted to do here was sketch some landscape features that might be associated with a glacier. And honestly, because it's going to be kind of difficult I can show you what I sketched. It is the simplest drawing I have ever created. And I labeled it a U-shaped valley. So you could also create there a drumlin or a kettle lake, but I like a U-shaped valley. That I think is the most important. Okay, and then there's a piece of popcorn here. All right, that's what I created, was a U-shaped valley. Now we're gonna go back to wherever it says Finger Lakes. So just a couple of things we need to know about the Finger Lakes. I'm assuming you guys have heard of the Finger Lakes. We had a picture of the Finger Lakes right there. So the Finger Lakes are called the Finger Lakes. They are in over near Rochester. They are called the Finger Lakes. I think you can probably tell why. They look like a bunch of fingers. And so how did the Finger Lakes get there? So the Finger Lakes are, what happened is there was already some existing river valleys there. So there was a whole bunch of rivers, and then the glaciers plowed through those river valleys, and they widened and deepened and accentuated the existing river valleys. And then the sediments basically dammed up those rivers, and then the rivers flooded behind the dam and created the Finger Lakes. You can actually tell which way the glaciers were moving because those Finger Lakes, they travel north to south. So you can see that those glaciers were traveling north to south and not east to west across New York State. Okay, so again, go ahead and get these 2 bullets into the Finger Lakes section on page 9. All right, so those are the Finger Lakes. And we have one more set of lakes we have to talk about. And I think most of you have probably heard about these guys. We got the Great Lakes. So the Great Lakes, which include Erie and Ontario, that are our good buddies next door to us near Buffalo. They formed at the end of the last ice age. So they're actually pretty new. So they're approximately 10,000 years old. In this case, glaciers actually carved out the basins that the lakes are now filled in with water. And they were filled with the melt water, so the water that melted off the glaciers. And surprisingly enough, these lakes actually contain about 20% of the world's fresh water. So we take those lakes we go to the beach in the summer as just normal to us, but they hold 20% of the world's water in just this world's fresh water in just this little corner of the world. I think that's kind of neat. So go ahead and get these into the Great Lakes bullet section. All right, so that is the notes on glaciers. We are going to move on. I think we have enough time. Let me double check on the clock here. Yep, we're going to move on to wind. So that is on page 8 for everybody. Just like we did for glaciers, I have a quick slideshow to show you, including a little video, and then just some big ideas to go along with it. So my first question would be, first of all, have you ever seen a tree like this, where the bottom curves like that and then it goes back straight? How do you think it got this way? What's happening to the underlying land? Like, what is going on here? One thing you might have noticed in this picture is that these trees are on a hill. We have a slope coming down this way. And what is happening is these trees and this land didn't always look like this. One thing that I'm pretty sure most of you already know is that plants grow towards the sunlight. And so trees will always grow up towards the light. You may have sometimes noticed me turning my plants there on the over on the windowsill so that because they start to curve towards the window. So I got to turn them every once in a while to straighten them out. So that's what's happened here is this land wasn't always sloped. These trees used to actually be, this land used to be flat, and this way used to be up. But since then, the ground has slid down and these trees have adjusted to that downward motion. One thing I want to say is gravity erosion is also called mass movement. So right away in the box on page 8, underneath the word gravity, I want you to put mass movement. So gravity and mass movement, they're interchangeable. Both phrases, gravity erosion and mass movement, they mean the same thing. And by mass movement, what it means is there is a large mass that is moving. So it's a large chunk of land that's moving. It's not just a few stones here and there. That first type of erosion that I showed you, that's called creep, and that's happening here too. I don't know if you can see from where you're sitting, but this is a fence and there's barbed wire or electrical fence. I think it's barbed wire going along this fence. And as you'll see, it's tilted. Now, I don't believe the farmer actually built this tilted like that. My guess is it was kind of on the edge of a cliff and the farmer didn't want their cows going down the cliff. So they put a fence there to prevent the cows from walking down the cliff and twisting an ankle or whatever. Well, now that cliff has slid a little bit and taken with it the land that used to be flat. And as you can see, these fence posts are now leaning. Now the fence posts, unlike the trees, they can't adjust themselves and grow straight up. So they're just going to stay tilted like this. This happens on even man-made things. So I believe this is an overpass. You can see like the bridge is probably up here, and this is that little incline that, little incline that leads up there. And these are drainage tiles. Again, they weren't built this way. These were all laying nice and flat, but gravity has slowly pulled these bricks down, down the hill, and they're buckling like this. Again, here's another example of those trees. You can see this. I see this on my drive from Eden to Pioneer every day on Genesee Road. There are tons of trees that look like this. And this is called creep. You can tell from the word creep. What does something do if they're, or someone do if they're creeping around? They're moving slowly, quietly, trying to go unnoticed. And that's what this is. Day to day, the farmer didn't just one day they were perfectly straight and bam, the next day they were leaning like this. In fact, the farmer might not have even noticed it. Day to day, they were moving down the hill and slowly but surely ended up like this. So creep is something that happens slow over time. So that's creep. That's different than a flow. If something is flowing, it's moving fast. It's like a landslide. In fact, it's like a landslide. So we got a whole pile of debris that just slides down a hill. This is the aftermath of a landslide. And one thing I want you to notice is look at the different rubble that's here, all the different debris. So debris is kind of like rubble. We've got big rocks, lots of tiny pieces of dirt, all different size sediments that were pulled down this hill. Again, just like with glaciers, gravity picks up everything. It doesn't matter if it's big or small, it mixes it all together. This is actually what's called a lahar. This is coming off of a volcano, but this is the ashes from the volcano that mix with water and kind of make it like a mud situation. And you can see that happened fast to that car. That wasn't like slow. That happened right away. This is, again, you can see that this looks like water, but that's mud. And this is a peak of a house. And these kids are standing on the peak of a house. A debris fall. And what's the difference between a flow and a fall? The flow is like water or like a liquid, where the fall is just bam, hits the ground. So you can kind of see here these, and I know this is a drawing, but this actually happens where giant chunks of the rock will just fall. Yeah, that one's not so good. Now, again, at the bottom of this hill, what do you see here? You see all these different size sediments. That's what you need to see, different size sediments. I love this picture. I think it's a little excessive here. We've got this giant mountain with this teeny tiny town here. But again, giant chunks will fall off the mountain. One thing I want you to notice is this slope right here. As these rocks fall off the mountain, they are going to start to pile up in this slope shape. So some of them will roll down the hill a little bit more and they'll start to pile up. You can see this at the bottom of any steep cliff around here. There's usually a pile of debris at the bottom of it, and it is always sloped like this. That's called a talus slope. Again, you can kind of see, so this was a rock fall on a roadway, but again, you can see that slope of the land. And again, here's another one. So this is called a talus slope, and the debris just piles up at the bottom at this angle here at the bottom. All right, for the big idea for gravity, here's what you need. So this is going to go on to page 8, right at the top for gravity. Again, gravity is the driving force of all agents of erosion. Gravity pulls sediments downhill. Sediments can be any size. Typically, they're going to be angular in shape versus round. We're going to get to round ones next week, and they're always unsorted. Go ahead and write these 5 bullets. Okay, so one thing before, I do want to show you another video like I did yesterday, but I do want to tell you what you're going to have for homework. So yes, you're going to have some Regents questions for homework. And I think what we're going to do is going to be, so remember how we just renumbered those pages? We're going to be doing pages 9 through 12. It's actually 20 Regents multiple choice questions, but we do need to go and cross off a couple. So if you could go to page 11, so whether it's the new page 11 or the one that you didn't even have to change, it's the page 11. It's got the map of New York and Connecticut at the top. I do want you to cross off question 10. It says the Harbor Hill Moraine. And I don't even know how to pronounce that next one. You can cross that one off. And it actually looks like that's going to be the only one you can cross off. So again, your homework will be the Regents questions on pages 9 through 12. And there are 20 of them. And again, you're going to put those into teams. I'm going to add that right now. Well, no, I can't do it right now. Sorry. But I do want to show you a video on on gravity erosion. If you want to work on your homework while watching this movie, that is fine with me. Let me make sure we have some time here. Oh yeah, we've got plenty of time, or should. All right, this video.
For me, Dropbox is a seamless way. Document.
This is one of my favorites.
Portland, Oregon, February 1996. A mountain begins to move, and for a contractor and his son, there's only one option: get out of the way fast. Oh my God! They had just gone head-to-head with one of nature's most powerful and destructive forces, a landslide. The surface of our planet is constantly reshaping itself, and landslides are a major reason. They strike wherever the soil is loosened by rain or tugged by gravity. It can be a rockfall or a raging river of mud. But wherever the ground fails, it can result in massive destruction. On average, landslides kill more than 8,000 people every year around the world. They can crash down without warning and travel for several miles. In the U.S., landslides occur in all 50 states, but some places are more dangerous than others. Landslides usually follow other natural disasters like volcanic eruptions, earthquakes, wildfires, storms, and floods. Steep slopes are obvious places for landslides, as are areas that have been hit by landslides before. But they also frequently occur where people have radically altered the landscape. Hills stripped of vegetation, slopes modified for roads and buildings. And as our cities and towns expand further, landslides become more frequent and more destructive. In 1998, disaster struck the Southern California suburb of Laguna Niguel. Few realized that the man-made hill beneath them could fail. The ground, eroded by heavy rains, began to give way, and the houses came crashing down. 7 were seriously damaged, and 5 of them tumbled down the cliff face. Though the ground cracked and the earth plummeted, no one was injured. The residents of Laguna Niguel were lucky. They still had their town. The following year in Venezuela, torrential rains triggered widespread landslides across a 25-mile-wide strip of coastline in the state of Vargas. Communities were buried under waves of mud and debris. It's estimated that 30,000 people were killed, around 10% of the area's population. Accurate death tolls were difficult to establish because so many people vanished under the mud or were swept out to sea. Though the catastrophe was on a massive scale, it is by no means unique. Such disasters have happened before and will happen again. As long as the earth continues to move, people will live with the threat of landslides.
That was that video with that the guy got on the back of the truck. What you guys who are so young don't realize is that was before everybody had cameras in their back pocket. That guy just happened to have a camcorder in his truck with him and was able to catch that landslide, which was crazy. Do I have time to show you one more quick video? Let me see what I got going on. Yeah, I think I definitely do. If I don't, you're gonna just have to stop it, but I want to show you one more video. I really like this next one too. And of course I've lost it. You'd think I'd be better at this by now.
Dramatic rock slide that will give any driver the chills. It began as a trickle, then it all came crashing down yesterday on U.S. Highway 64. Yikes, it was the second rock slide that morning. Crews had to break up the car-sized rocks to clear the road. Good morning, everybody. How about that? Man, look at that.
So the road wasn't blocked off at the time yet,
Wasn't
even though
it?
there had been a
Where
previous.
was the
Oh
camera?
no!
That's
Good
like,
question.
We are
who took
everywhere.
that-
We are everywhere.
Great question.
I'm just going to sit here until these rocks
Look at
come
that.
down.
That is amazing.
Well, there had
Stunning.
been a couple of previous ones. I guess they were watching.
I'm late, honey, I'm late.
Well, you know
It was
what?
a rock slide.
Oh, yeah.
Right.
Okay, so now that you've seen those, it looks like you should have some time to work on your homework. Just like I did last time, there is a Teams assignment for you to submit your work onto Teams. That way I can check, see how you're doing. I am going to make you get a 65. So there were 20. We took away one question. So you do need to get 12 of those 19 questions correct to get credit on the homework. So get those submitted and I will talk to you on Monday.